Okay, so this lab is called the Kinetics of a Crystal Violet Reaction. We're going to be measuring the speed of a reaction. There are two reactants involved, and so we're interested in knowing what is the order of the reaction with respect to each of those. And we'll also be able to compute a rate constant for the reaction. Here's what the reaction looks like. On the reactant side, we have hydroxide ion as reactant 1, and the crystal violet cation as reactant 2. As its name suggests, if we had this substance dissolved in water, it would produce a violet color. We would be seeing a violet solution here. And what we're going to be doing is adding a base to it, sodium hydroxide, but it's the hydroxide part of it that reacts. And that hydroxide will add to this central carbon, as you see here in the product side. The resulting compound has no color. So as this reaction proceeds and we add the hydroxide, we have a purple solution that eventually loses all of its color, and it's just a clear, colorless solution. Because of that color change, we can monitor the speed of this reaction by using a spectrometer. A spectrometer can measure the intensity of the color, and as that intensity decreases, the instrument that we use will measure that decrease, and that will be proportional to the concentration. I wanted to share with you a little bit more about these structures, and these models that I'm about to show you, you can get to through Canvas. It's the first link in this module. You can click, and I encourage you to look at these models and understand more about the structure of crystal violet by looking at the model. This is crystal violet that I'm showing now. We can rotate it. You see that it has a central carbon here labeled as carbon 1 with 3 carbons attached. And it's pretty much a flat structure there. So we would say that the carbon at the center is sp2 hybridized. There, we're linking something back to what we've talked about earlier in the course. This is an sp2 hybridized carbon, and it is a flat 4-atom structure here at the center. And then coming off, you have 3, they look like propellers almost in this molecule. They're all equivalent. There's a 6-membered ring on each propeller, and then a nitrogen, and then 2 carbons on the end. They're all identical. And when the molecule is in this form, it's overall charged +1, it's a cation. When it's in this form, the electrons that are in each of these propellers, as I've called them, they're rings, they can easily move back and forth from one propeller to the next through this central carbon. And because of that motion of those electrons, that's what gives it its violet color. Violet color is produced when these electrons are moving and they relax from an excited state to a ground state, giving off that purple color. Now, when we add hydroxide, when we do the reaction, what we're doing is we're kind of destroying that. Let me show you what the product looks like. Here's the crystal violet with the hydroxide added. You see the red oxygen with its white hydrogen, right? It's now added to that central carbon. And if we look at it, we no longer have a flat structure, but instead we have what would be an sp3 hybridized carbon. It would be tetrahedral. And now with the propellers in this orientation connected by an sp3 carbon, the electrons cannot move from one ring to the next, and it destroys what is producing the violet color. So take a look at those models. It gives you a better understanding of what's happening in this experiment at the molecular level. How do we obtain the data? Well, if we were working in the lab this week, we would use a spectrophotometer. We would prepare a small sample in what's called a cuvette. We have glass versions of these and plastic versions of these. And you prepare a sample and you simply insert it in the device. And inside this device, there's a light source that's passing through a prism so that the sample can be exposed to specific wavelengths of the visible spectrum. And some of those wavelengths will get absorbed by the sample and others will not. And what is not absorbed gets detected at the other end. And there's then a digital display, or this could be interfaced to a computer as well. But either way, you end up with a digital result for what is the absorbance, how much of the light has been absorbed by the sample. And the amount of light absorbed is directly proportional to the amount of the substance in there, in this case, crystal violet. So as the reaction, at the starting point, there's going to be a lot of light absorbed, but then as the reaction proceeds, there'll be less and less light absorbed, and we can measure that with this device. And we can basically equate the absorbance to the concentration. So there's a proportionality constant, but it's basically the same information that we need about the concentration. And we can watch this as it depletes over time to get what is the rate. Oops. So I'll come back to the handout here. And the equations that we'll be using to analyze the data are all summarized here. First off, we can see our goal in this lab is to figure out, here's the rate law as you would write it. Rate equals K times di to the X, OH minus to the Y. This is the generic form of the rate law. And we will want to find out what is K, what is X, and what is Y. So the experiment that we do today will allow us to determine those three parameters of the rate law. And the way in which we tackle this first, since there's two reactants, we kind of want to take the hydroxide out of play here for a second. And what we do is we make sure that the hydroxide is in great excess when we're mixing it with the crystal violet. And so it's almost like a constant, right? Yes, a little bit of the hydroxide reacts, but for the most part, this whole thing will be a constant. And so I can rewrite the rate law so that it only depends on the dye. And I have a modified proportionality constant here, K prime. And K prime would be equal to K, the actual rate constant, times the hydroxide raised to the Y power. So we're going to be able to use these equations directly then with the data. First, we're going to determine what is the reaction order with respect to the dye. We're going to figure out what X is by just plotting the concentration versus time, and then the log of the concentration versus time, and then 1 over the concentration versus time. If you recall from your lecture on kinetics, we have to examine each of these to see if it's 0, first, or second order. So we'll know X, that'll be the first thing that we determine. Then because we know X, we can calculate K prime from this equation using any of the rate data that we could choose rate data, or we could average all of the data to determine an average K prime. Then we'll move on down to this last equation. And because we're going to be doing 2 trials with different concentrations of hydroxide, we'll be able to plug in this equation and solve 2 equations, 2 unknowns. The K, we'll know the K prime and we'll know the hydroxide for 2 different trials. So it'll be applying this equation 2 times, 2 equations, 2 unknowns, to solve for K and Y. And at that point, we will have determined all 3 parameters from the kinetics data. The lab write-out continues. It shows you all the procedures that we would follow, the amounts that we would use. You need to read that, be familiar with it, maybe have it open as you do the simulation, because you're going to fill in things that are listed there in that procedure. But I'm going to move on now to the simulation itself. You'll download this Excel file in order to generate your data. Everyone's data will be slightly unique because there's a random number generator behind the scenes here that basically produces unique data every time the simulation is run. So if you have a friend and you're looking at their work, numbers are not going to match up exactly, but the results should. You put in a trial number because we're doing this, we're going to be using this 2 times. So this just lets you know which trial we're working on. From the experimental procedure, you'll put in what's the concentration of the OH minus the sodium hydroxide that we're using. And then you'll specify 2 volumes, how much of the hydroxide you're going to put in. And I'm going to just make up some numbers here that aren't the ones that you'll use, just so I'm not doing exactly what you're going to be doing. You'll put in the volume of this hydroxide solution and then the total volume. And so we'll put in there, I'm again making up a number. So instead of putting in the volume of the hydroxide and the volume of the crystal violet, we're putting in the volume of the stock and what is the total for that trial. And the other substances just make up the difference. That's the end of what you would type in, just those 4 cells. The rest of this is generated by clicking on buttons. Although you would be able to calculate this by clicking on the concentration button, this will do the calculation for you, and you can check it out if it should be the same that you would calculate. But this provides the initial concentration of the hydroxide. And then the next button gives you the initial absorbance. Now, it didn't work for me. Look, I'm demonstrating that I made up numbers here that I was just playing with numbers. I picked numbers that it doesn't like. So this won't happen to you if you follow the procedure. So I thought I'd get away with this, but I'm not. So now I've got numbers that work. It's a little more sensitive, this simulation, than I expected. So clicked on the initial hydroxide. I clicked on initial absorbance. So this would be at the start of the reaction, the time 0, the initial absorbance, before it starts to react. And now I will click on the increment time button, and time moves along here and is recorded 37 seconds. And what is the absorbance? You see it's gone down. And the graph is going to be graphing this for us as we go along. I can increment time again, 79 seconds, 122 seconds. It's just showing us how the absorbance is changing. In other words, how the concentration is changing as a function of time. And I can keep clicking on this until I'm satisfied I have enough data. Already you can notice just from the graph, you don't have to look at the numbers, just the graph. This isn't linear. So this is not zeroth order. This has got a curve in it. Starts out fast and then slows down over time. I can keep clicking on this till I get to about 600 seconds would be enough. And in fact, the simulation won't let me go too much beyond that. Eventually, it'll give me a little message telling me, you've got enough data. No sense going any further. And also, in real life, if you were doing this, you'd be watching the absorbance until it goes down to essentially zero. And that's how you would know that you'd be done or you've collected enough data. So there's no need to record these numbers. You'll be able to copy and paste these directly into your own Excel spreadsheet. The spreadsheet that you download, which is the simulator, doesn't let you edit. You can't go and create tabs or anything, but you can create a new blank document, and you can copy and paste this data so that you didn't have to write it down, right? I'm just going to copy, and then I'm going to come down in the, not at the very top, but come down to B3 and paste that data in. And there's actually another point that you can add to this, and that's the initial absorbance. That's for time equals 0. So I'm going to copy that data, 2.978, and paste that in and call that time 0. Now I can label my data, time in seconds. And this is absorbance. And what I'm going to want to do to determine whether this is 0 first or second order is I'm going to plot the absorbance versus time, and then I'll plot the natural log of absorbance versus time, and then I'll plot the 1 over the absorbance versus time. Maybe I'll just call this A, make it a little cleaner. So I can center all of this. And so this is trial 1. I have my data for trial 1 copied from the simulator into my own document. And now I can generate the other columns needed for the analysis by just using the formula ln equals ln of, and then click on C2. And then the formula next, I can do equals 1 over C2. So now I've got ln of A and 1 over A in the next two columns. And I can select those two and move my mouse to the lower right-hand corner until it's a solid plus sign. And then holding down the mouse button, the left mouse button, drag down. And that simply fills out that formula so that I have the ln of A for all of these values and 1 over A for all of these values. Now it's time to make my graphs. The first graph I want is just the absorbance. So I just highlight those two columns, insert graph. That in Excel language, that means insert a chart, and I'll choose the scatter plot. And that plot should look something similar to what my simulator had shown. And I can, of course, put a trend line on for that. I right mouse clicked on the data and put an equation and the R squared value on there and moved it so I could see the equation. So there I've got my first graph. The next graph, I can select time and then holding down the control button, I can select the ln of A. So now I've got these two columns selected and I can insert that graph in the same way. And I can add, right mouse click on the data, add a trend line, put the equation and R squared on it, move it so I can see it. And make it a little smaller. And then the last one, right? Highlight the time and then holding down control, highlight 1 over A and insert that graph or chart as they call it. And there's 1 over A. And you can try to make that into a line. Although the only data that really does look like a line is the ln of A. So we've determined, which one here is the best fit, and it would be the ln of A. You'll go through this for a second trial where you've changed the hydroxide, and you'll gather all of that data. But when you do the second trial, you don't have to do all 3 graphs. You can just do the one that is linear. You won't need to do all 3. This first trial is sufficient to determine whether it's 0 first or second order. Now, you're going to put all of this in your report sheet. So I wanted to show you how to do that. So here I'm sitting in Excel with my data for trial 1. And I'm going to open up the report sheet. You see here, you can fill out your name. You can put in the quantities that you used in the simulation, fill out that table. And then there's a Kinetics data table, and it has the same columns as what we had in the spreadsheet. So I'm going to go back to the spreadsheet, and I don't need the headings because I've got the headings in the report. So I'm just going to go down and select these, looks like 17 rows of data. And I can copy that whole thing. And then I'm going to highlight again 17 rows of data, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and then paste it. I'll be careful how I paste it. I think what I want to do is overwrite the cells. There's some options here. You don't want new rows. You don't want a new table. You don't want to nest the table. You want to overwrite the cells. And then it just pops them right in there. Same thing for the trial 2. There's also a place for you to put your graphs. And you see now why I made them sort of tiny, because I want them to fit. If you can resize them before or after, it doesn't matter. Here, I'll take the first one and I click on the graph and copy. And I'm going to put it in here, absorbance versus time, so I can paste. And that one just fit. But if it didn't fit, you can always resize it within Word and make it fit within the table. Then the calculations are underneath here, and we even remind you in the report template which calculations to use. So hopefully that will go straight forward. You'll do your calculations and report your results. You'll answer the discussion questions, and you'll submit your report. And maybe everything will go smoothly, and you'll be able to turn that in, or maybe not. And if not, it's no problem. You just come back to the Zoom session, ask me a question. I'll share your screen, or I can walk you through it. If it turns out you submit something and I grade it and you get a low score, just we'll come in next week and we'll correct it and submit it for full credit.